Gel filtration chromatography. Chromatography, it is the technique used for the separation of chemical substances and particles by different movement through two-phase system, in which the movement is affected by the flow, liquid or gas mobile phase, which precolloids through the adsorbent stationary phase or second liquid phase. Gel filtration chromatography, it is otherwise known as molecular extraction chromatography, gel permeation chromatography. Mobile phase liquid, stationary phase porous beads material will define for size. It separates molecules according to the differences in sizes as they pass through a gel filtration medium packed in column. Unlike ion exchange or affinity chromatography, molecules do not bind to chromatography medium. It is generally used to separate biological molecules and to determine molecular weights and molecular weight distribution of polymers. Partition coefficient or distribution coefficient is the basis of all types of chromatography for two immiscible phases, mobile and stationary phases. The value for this coefficient is a constant at a given temperature and is given by the expression molar quantity of sunlight stationary phase, molar quantity of sunlight in mobile phase. Effective average distribution coefficient, molecules absorbed in stationary phase, molecules absorbed in mobile phase. Void volume, it is the volume of mobile phase Vm or V0 in a column. In ideal, it is equal to mobile phase hold up volume. For example, if the stationary phase occupies 40% of the total column volume, the void volume would be 60% of total column volume. Molecules that do not enter the matrix or eluted void volume as they directly pass through the column has the same speed to buffer. A mixture of molecules dissolved in liquid, the mobile phase, is applied to chromatography column, which contains a solid support in the from microscopic spheres or bits, the stationary phase, the mass of bits within the column is often referred to as the column bit. The bits act as traps or sieves and functions to filter small molecules which become temporarily trapped with the pores. Larger molecules pass around or excluded from the bits. Large sample molecules cannot or can only partly penetrate the pores. Various smaller molecules can access most or all pores. Thus, large molecules elute first, smaller molecules elute later, while molecules that can access all the pores elute lost from the column. Particles of different sizes will elute filtered through the stationary phase at different rates. Medium stationary phase, semi-permeable porous beds with well-defined range of pore size. Beds or cross-linked polymers, degree of cross-linked in rapid dissolving of proteins or for protein purification. Intermediate pore size are used to separate relatively small proteins. Very large pore size are used for purification of biological complexes. Stationary phase is used for the gel exclusion chromatography, include dextran and dextran polycrylamide separacy. Each is available with variety of different ranges of pore size in the beds, permitting separation macromolecules of different size. It should be chemically inert, it should be chemically inexpensive, it should be not react with component to be separated, it should be not react eluent, it should be not colorless, uniform in size and shape, it should be mechanical stable. Classification of gel, soft gel, example dextran separax, separation of protein. Semi-rigid gel, example BioBits, separation of non-polar polymers in non-polar solvents. Highly rigid gels and glasses, separation of polar systems. Mobile phase, the liquid used to dissolve the biomolecules to make the mobile phase is usually called a buffer. The mixture of biomolecules dissolved in the buffer is called the sample. The choice mobile phase to be used in any separation will depend on the type of separation to be achieved and component to be separated. The solvent must dissolve the sample completely. Column, shorter columns save time and solvent. Small particles, timing 5 mm provide a better resolution. On other hand, 5 mm or even 3 mm packings are more sensitive towards contamination by samples, contamination impurities. Particles as large as 20 mm have been recommended for very high molecular weight polymers. Columns with different porosity or mixed bed columns provide a better separation. Advantages: short analysis time, well defined separation, narrow bands, and good sensitivity. There is no sample loss. Sample amount of mobile phase required. The flow rate can be set. Disadvantages: limited number of peaks that can be resolved within the short time scale of GFC run. Filtration must be performed before using the instrument to prevent dust and other particles of running columns interfering with the detectors. Applications: protein fractionation, purification, virus enzyme, hormone, nucleic acid, molecular weight determination, globular protein, separation of sugar proteins, peptides, rubbers, and other bases of the other size. This technique can be determined quaternary structure of purified protein. Reference